Very good evening, all. So today we are starting with the topic amines. Welcome to SPSVERSITY. I'm here, your chemistry educator. Hope you all are doing really good. So let's start with this concept, amines. Okay, so what are amines and where do you find them and what is the smell? Generally, whenever we say amines, we see that they have this fishy smell. Okay, so what is the fishy smell? If you go near the market, fish market, you get that bad smell, and even the smell of fertilizers which contain ammonia, and also the urine. All these have almost the similar kind of smells. So the amines are the compounds in which NH2 acts as a functional group. Or if you have the ammonia molecule, which is NH3, if one or more than one hydrogens of ammonia is replaced by alkyl group, then it is called as amines. So here we go. Yeah. So if you have the ammonia like this, ammonia molecule, you replace one of the hydrogens, you get RNH2. You replace one of second hydrogen also by the alkyl group, then you get RNHR. You can even replace the third hydrogen by alkyl group, then it is RNR in one more R. So in all these cases, nitrogen is going to have a lone pair of electrons. And then what is the structure? So it is not spa hybridized, it is sp3 hybridized. So everywhere, just like the ammonia molecule, the amines are sp3 hybridized. The nitrogen, which is present in amines, is sp3 hybridized. And because of the lone pair of electrons which are present on the apex, this is pyramidal in shape, where the nitrogen is in the center with the lone pair of electrons on the top. And there are three alkyl groups or the hydrogens which are present down at the base. Okay. And this is going to give the molecule a pyramidal geometry. This is about the structure of ammonia, primary, secondary, and the tertiary amines. Then we say what exactly we are going to find out. What exactly are the primary, secondary, and the tertiary amines? Whenever you say ammonia, there is no carbon atom. It's NH3 only. So that's called as ammonia. And if you replace one hydrogen of ammonia by one alkyl group, that means two nitrogen, one carbon is directly attached. This is called as primary amine. So if you have NH3 and you replace, this is NH3 molecule, you replace one hydrogen by alkyl group, so you get RNH2. The nitrogen in amines is attached to directly attached to one carbon atom, so it's called as primary amine or 1 degree amine. Now what you're going to do, you're going to replace two hydrogens, in the primary amine, take away one hydrogen and put one more alkyl group in that place. This is going to give you the secondary amine. So there are two carbons which are directly attached to nitrogen. This is going to give you the secondary amine. And all the hydrogens of ammonia molecules are replaced by alkyl groups. Then it is called as, it can be aryl group as well. So three carbon atoms, so it is called as tertiary amine. Then there is one more possibility where the lone pair of electrons are given to an alkyl group to form the bond, and nitrogen, because it has given the lone pair of electron to form the bond, and there is one more ion exists in the solution, say X minus or Cl minus. This is called as quaternary ammonium salt, just like NH4Cl. What is that called as? Ammonium chloride. If you replace the hydrogens of ammonium chloride and if you replace the hydrogens by the alkyl group, then it is called as quaternary ammonium chloride or quaternary ammonium salt. This is depending on this classification is depending on the number of carbon atoms which are directly attached to nitrogen in the amines. Okay. Now we'll go to the next topic. How do you name them in the IUPAC nomenclature? So since the amine group doesn't contain any of the carbon atoms, you have to follow the longest chain rule first. And once you do the longest chain rule, what you're going to see is, once you find out the longest chain, what you have to do is, you have to set a chain that if there is only one functional group, that is amine, then you have to set in such a way that the amine group gets the lowest number. The carbon which is attached to the Can you see me by any chance? Because I can't see myself. Yeah, showing. Just give me a minute if I'll just check. Sorry if I am teaching and if you can't see me, that's why I'm just ensuring that you can see me. Okay, yeah, we'll go ahead. Yeah, it started 5 minutes ago. That's fine. It's cool. Then, so we have a chain over here. So for example, if it is CH3NH2, first you identify whether it's a primary to secondary or the tertiary amine. Say the compound is CH3NH2. So only one carbon atom. So the root word is meth, type of bonding is ane. At the first position, amine is attached. No need to mention if it is at the first position, methanamine. So in this chain, you have to select 4 carbon atoms and the NH2 is attached to the first carbon. So it is called as aminobutane, or the IUPAC name is butane amine, and you cancel out the first vowel when you name it. And this one, what are you going to name it? You select the longest chain possible. This is the longest chain which contains 3 carbon atoms, and to the second carbon atom nitrogen is attached. So now what you're going to say this as? At the second position methyl group is as well. So 2 methyl propane, 3 carbon atoms, 2 amine or 2 propanamine. Now this is a secondary. So this is how you name the primary amines. What do you mean by the secondary amine? If NH is attached to 2 CH3s, then one can be selected as a long chain which contains NH2. So if you select this as a longest chain, there is one carbon atom in the chain. So it is meth, type of bonding is ane, amine. Now for this nitrogen, a CH3 is attached, which is the prefix. So it becomes N-methyl. It is N because the methyl group is attached to the nitrogen. We'll go for the one more example. If you have CH3, NH, C2H5. Now the longest chain is the one which contains more number of carbon atoms. So this becomes the longest chain which is attached to NH. So it is ethanamine. And this methyl group is attached to N, so it is N-methyl ethanamine. Now you go for the for this, in this example, it is a propyl group which is longer, or the 3 carbon atoms, so it is N-methyl propanamine. And say you have the tertiary amine in which you have different groups, CH3, C2H5, C3H7. Then the one with the largest number of carbon atoms becomes the longest chain, so you call it as propanamine. And for this N, there are 2 groups attached. One is methyl, the other one is ethyl. Since in the alphabetical order, ethyl comes first, so you call it as N-ethyl, because both ethyl and the methyl groups are attached to nitrogen. So it is N-ethyl, N-methyl propanamine. Or if you take this example, this is the longest chain, which is ethanamine, and 2 methyl groups are attached. So it is N, N. So you have to mention the position always. It is attached to N. So N, N, dimethyl methanamine. This is how you call the compound as, and this is how you name the primary, secondary, and the tertiary amines. You select the longest chain and see the number of carbon atoms in that particular chain. After that, give the name, mention the type of bonding. At the end, you add amine and cancel out the vowel. Once you are done with the nomenclature of the longest chain with the amine group, select what is not included. If it is a primary amine, there won't be anything before it. If it is a secondary amine, you have to attach one group with the, starting from N, because that particular group is attached to N. If it is a tertiary amine, then what you have to do is mention the position of which groups are attached to N. You have to find out that and add N. If it repeats once, if it repeats twice, N comma N die, like that you have to use. Then how do you name the aromatic amines? Aromatic amines are those in which NH2 is attached to a benzene ring. Aromatic compounds are those which have the characteristic aroma and they have at least one benzene ring in them. So that's a general way of expressing the aromatic compounds. So if you take the aromatic amines, then there is NH2 which is attached to benzene. So it is aminobenzene or benzenamine, or the common name of this is aniline. And if this is the case, so this is the longest chain now. That's a aniline. In case of aniline, you have CH2, CH3 attached to nitrogen. One of the hydrogens of aniline is replaced by ethyl group. So it is N-ethyl aniline. Now these are not the IUPAC nomenclature. These are the general names. This is aniline, to which this is the ortho position. So orthobromoaniline. Here para 1, 2, 3, 4. You can name it as 4, or this is the para position, para nitroaniline. And if the methyl group and NH2 are attached to the same benzene ring, then it is called as tolbidine. Okay, if NH2 and OCH3 are present in the same compound, then it is called as anicidine. And you name the positions accordingly, like 2, 3, 4, 5, 6, or you can also mention them as orthopara meta, orthometa para, this way. Then how do you prepare amines? That's the next question. Let me see if anyone is watching. Keep supporting, guys. Okay. Yeah. Now, the general methods of preparation, how the amines are prepared. The first method is ammonolysis. What exactly is ammonolysis? It is the bond between, if you take any alkyl halide, this is going to have, let me change the color of my writing so you shouldn't get bored with the same color. So if you take alkyl halide, then the bond will be there between C and X. If this bond is broken by ammonia, then it is called as ammonolysis. Lysis is breaking. In the presence of ammonia is called as ammonolysis. This is also called as Hoffmann ammonolysis. Don't get confused with the Hoffmann degradation and the Hoffmann ammonolysis. Hoffmann degradation is decrease in the number of carbon atoms and the reaction conditions are quite different, whereas Hoffmann's ammonolysis is a treatment of alkyl halide in the presence of ammonia. So you have to take the aqueous solution of ammonia and then it is heated in the presence of alkyl halide. So what you can do is, I'm writing the reaction over here. So you have Rx and you have NH3. Say this is C. I'll write it as C. This attacks the lone pair of electron. This attacks C and that helps in the cleavage of CX bond, and at the end if you can write this as HNH2, then X will go with H and you get RNH2. I'll write R and H as RNHH. If you're going to treat it with one more molecule of Rx, from here H will go, from here X will go, and you get RNHR. Now, if you're going to treat it with one more molecule of Rx, then the HX will go, and in that position, you will have RNRR. So, you started with one molecule of alkyl halide in the presence of ammonia to get the primary amine, which on further reaction with alkyl halide gives the secondary, which will give you the tertiary. And if you treat it with one more molecule of Rx, that gets attached and you get RNRR plus charge because there is one more alkyl group and X minus. This is quaternary ammonium salt. In case if the excess ammonia condition is mentioned, if you're not going to treat this way, or you can treat treat Rx plus 2 NH3, NH3 plus 2 Rx. This kind of questions might be asked from this, where you should be aware what you are going to get if you start with NH3 and 2 molecules of Rx. 2 HX are removed and 2 R get substituted for nitrogen, and you get the secondary amine. If NH3 plus 3 Rx, if you are going to treat, that is going to give you the tertiary amine. Instead, if ammonia is, that's a solution of excess of ammonia is treated with the alkyl halide, then you are going to get the primary amine. If you just heat Rx with ammonia, you are going to get the primary, secondary, tertiary, as well as quaternary. So it's a mixture of product. But if you take the excess of ammonia, only one product will be formed. That's the primary amine. Is a main product, I can say. The ammonolysis of alcohol. The same way, in case of alcohol, just like alkyl halides, this bond can be broken in the presence of amines, and that may give, here water molecule is a byproduct. You can get the primary amine, secondary amine, and the tertiary amine. Because here, if you treat it with 1 mole molecule of ROH, you don't get the quaternary ammonium hydroxide because of the steric hindrance. And just like the previous case, if you use excess of ammonia, primary amine will be the main product. And by reduction, how do you define reduction as? Reduction is addition of hydrogen or the removal of oxygen. Both can happen in the presence of a reducing agent, leading to the formation of the corresponding products. So we'll start with the first one, RCONH2. This is called as amide. So RC double bond O NH2. When you reduce it using a strong reducing agent like lithium aluminum hydride or sodium over ethanol, then this double bonded O group gets replaced by the hydrogen. So you get RCH2 NH2. You're going to get the primary amine. Okay, if these hydrogens are replaced by alkyl groups, then accordingly you'll get the secondary and the tertiary amines. And the second one, with corresponding with the alkyl cyanides. When alkyl cyanide is treated with sodium over ethanol, so you have R C double bond N. So the hydrogen may get added over here like this, and you get RCH double bond NH, which is called as imine, which on further reduction, hydrogen get added and you get RCH2NH2, which is a primary amine. And this particular reaction is called as Mendius reaction. In this method, you can't prepare the secondary and the tertiary amines. Okay. The reduction of alkyl isocyanide. In the same reaction, in the same way, if you take isocyanide, then you can get the secondary amine, where the addition takes place to carbon and the nitrogen. And with oximes are the compounds which contain CH double bond NOH. If you reduce it in the presence of lithium aluminum hydride, see in most of the reactions of amines, you are going to use lithium aluminum hydride or sodium over ethanol. So you can make it as a point where most of the reactions use the same reducing agent, strong reducing agent. When the oxime is treated with oxime is reduced, then what you are going to get? So first here the hydrogens get added and this OH goes, as a result you get CH2 NH2 along with the water molecule. If you take the nitro compounds and if you're going to reduce them in the presence of tin over HCl, or you can even use iron over HCl, which is which replaces these oxygens by the hydrogen, so you are going to get the primary amines. These are how you do the reduction. Then we have the next method that's called as Gabriel Thalimide synthesis. Gabriel was the scientist who used this method for the preparation of primary amines. And the Thalimide, it's called Gabriel Thalimide synthesis because the starting material is Thalimide. So how do you get Thalimide? Say, what is imide? I'm just writing, just for your understanding. This is called as phthalic acid, where you have COOH attached to the neighboring positions of the benzene ring, and if you treat it with NH3, two water molecules are removed like this, and you get C double bond O, C double bond O, NH. This is called as Thalamide. So the starting material for the synthesis is Thalamide. We'll start with the Thalamide in the beginning. The Thalamide, C double bond O, NH, is treated with the potassium hydroxide, that ethanolic potassium hydroxide, that's KOH. Then a water molecule is eliminated like this. You can write so minus H2O, and what you're going to write it in the next step, CO, here also CO, N minus K plus, because OH minus takes the hydrogen and that bond shifts to nitrogen, so N gets a minus charge. Then this molecule is treated with RX, alkyl halide, where K will go with X as KX, and you get minus KX, and I'm writing it over here, benzene ring. Sorry, my benzene ring is bit awkward. C double bond O and N, to which alkyl group is attached. Alkyl substituted Thalamide. Now, this is treated with NaOH. When you treat it with NaOH, say this is two molecules of NaOH, what is that you're going to get? Say I'm treating it with NaOH and NaOH, which contains ONA, so this will go together as R and NH2, plus you're going to get disodium salt of, that's CO, and remaining comes together ONA, and here also it is EOONA. By this method, you can get the primary aliphatic amine. Why can't you prepare the aromatic amine? If you see here, this goes and attacks R, and this shifts over here. That's how the reaction proceeds. Where if you replace it by the benzene ring with RX, this doesn't undergo nucleophilic substitution. It always undergoes electrophilic substitution, not the nucleophilic substitution, because benzene is electron rich. That's why this doesn't give you the aromatic amine. Then we have the Hoffmann bromamide degradation reaction for the preparation. It is called as Hoffmann bromamide degradation because by this method, if you start with 2 carbon atoms in the original compound, that's a reactant, that's an amide. Easy to remember. In case of bromamide reaction, what you have as the starting material is, it's a combination of two words. One is bromine, the other one is amide. When amides are treated with bromine in the presence of alkali, and when they are heated, corresponding amines are obtained. So you take the primary amines are obtained at the end of the reaction. You start with amide and you treat it with the bromine water in the presence of bromine and aqueous or ethanolic solution of sodium or the potassium hydroxide, and you see 2K from here will combine with Br2 to give 2KBr, and the CO from here will go with 2 more K as K2CO3, and 2 molecules of water are obtained, whereas this goes from middle. So you get RNH2. The primary amines are obtained by this step. So this is degradation. From the alkanoic acid, that's from the carboxylic acid, if you are going to treat it with hydrozoic acid, that's N3H, in the presence of concentrated sulfuric acid, then a nitrogen gas escapes from here. This CO2 gas also escapes from here. What you are left with are with one NH here and one more NH here. So it gives you the primary amine. Now we are going to the basic character of amines. Amines are considered as weak bases. The basicity is due to two factors. It can accept the protons as well as it can donate a lone pair of electrons. Okay, now we are starting this with the formation of salt. They are called as weak bases. Whenever acid reacts with the base, you are going to get a salt. So same way, compared to water, these are strong bases. So how do you call them as a base? This is a base which reacts with an acid to give RNH2X, that reacts to give this lone pair of electrons, take up hydrogen, so you get RNH3 plus and X. If you do it with the aniline, you get the anilinium chloride, RNH3 plus and the Cl minus. This on reaction with the base again, that's going to give you H plus, the OH minus, which is a strong base. If you treat this salt with the strong base, then that strong base is going to abstract a proton from this salt, and by which you are going to get the amine back. Whenever you say the basicity, you have to consider three major factors. What are those factors? Yeah. So you have to consider substituted amines. In case of substituted amines, the alkyl groups attached to it. And the second one, the bulkiness of the groups. And the third one, of groups attached. And the solvation or the hydration in the solvent. This is depending on the hydrogens present. Alkyl groups result in the plus I effect. So how, depending on all these three, you're going to give the basic strength for the amines. So if you take ammonia, only ammonia. Ammonia is considered as a weak base because it's going to give its lone pair of electrons and it's a weak base. If you take the primary amine with an example of CH3NH2, alkyl groups are electron donating groups. They show the plus I effect, because of which electron density on the nitrogen increases. When the electron density on nitrogen is going to increase, that can give the electron pair very easily, and it is comparatively stronger base compared to ammonia. As well as if you see the bulkiness, two hydrogens are there which are attached to nitrogen. They are not bulky, they are the smaller groups, and there is only one methyl group. So the steric hindrance doesn't come into picture over here. If you see the hydration, it's the hydrogens which are present with the nitrogen, they can form the hydrogen bond. So these two nitrogen can form the hydrogen bond. More is the hydration, greater will be the stability. Okay, so consider these three factors when you compare it with the ammonia. Though ammonia can undergo solvation more easily or with a greater chance, but the presence of the electron donating alkyl group increases the electron density on the nitrogen in the primary amine. So primary amine is a better base compared to ammonia. If you take the secondary amine, you start with the secondary amine, say CH3, NH, CH3. There are two electron donating alkyl groups which is increase electron density on nitrogen, which can be given still more easily, and it is a stronger base compared to the methylamine. Again, there are only two groups attached to the nitrogen in the amines. So there is one hydrogen which can form the hydrogen bond. So there is the presence of plus I effect. The compound is not much bulky, and there are hydrogens for the hydration. If you take the tertiary amine, where all the groups are replaced of ammonia are all the groups all hydrogens of ammonia are replaced by methyl groups. In this case, what happens is the lone pair of electrons on nitrogen cannot be easily given because of the bulky groups, that's due to the steric hindrance. So there is no hydrogen for the solvation also, though there are three groups which are electron donating. Because of the presence of steric hindrance and no hydration, this is a weaker base compared to the secondary amine. So whenever you are asked to compare the basic strength, you have to consider all these three factors and write the answers in the examination. Hope you get it, what we have done now. So if you are asked to compare the basic strength of the primary and the secondary amines, what you're going to do? If you're going to compare the basic strength of the primary and the tertiary amine, in the tertiary amines, you have to say in case of tertiary amines, there are more electron donating methyl groups which show the plus I effect, because of which it is more basic compared to, it's a stronger base compared to methylamine, where there is only one group which can donate the electron, which is electron donating group, that's the methyl group. But these if you balance all these three, then the primary amine can form the hydrogen bonds, as well as it is not bulky, and there is no steric hindrance. Because of these three factors, considering these three factors in primary amine, it is a better base than the tertiary amine, where the steric hindrance plays a major factor. So with the substitution, if you can see, if it is a ethyl group, then the order is different. If it is a methyl group, then the order is different. In both the cases, generally the secondary amines are most basic. If it is a ethyl group, then the plus I effect will be more. That's why the tertiary amine is more basic compared to the primary amine. Whereas in case of the methyl groups which are substituted in amines, then the primary amine is more primary amine is more basic than the tertiary amine. So considering these factors, we have to explain the basic strength. We'll go to the aryl amines. The aryl amines can also react with acids. They form the salts. Here, they also form the aniline ion, but the lone pair of the nitrogen are involved in the resonance, so they are less available for donation. So they are comparatively less basic. That's why the pKb value, the pH or the pOH, whatever we add P, that makes the substance less acidic or less basic. So since the pKb values are high, it's the weakest base compared to the regular alkyl amines. Now, more is the number of resonating structure, more will be the stability. Okay, so if you compare the anilinium ion, if it is anilinium ion, there are only two resonating structures, as shown in this figure. If you can see here, only two resonating structure. If you take the aniline, there are 5 resonating structure, because of which aniline is more stable than anilinium ion. Okay. And also, the presence of electron withdrawing groups increases the acidic strength. For example, if you have aniline with NO2 group attached to it, NO2 is electron withdrawing group, so it withdraws the electrons from the ring. So what happens to the basic strength? We are speaking about the basic strength. NO2 is the electron withdrawing group, so that decreases the basic strength. In the lone pair of nitrogen are involved in the resonance, as well as the electron withdrawing group is there, so basic strength is going to decrease. If you have electron donating groups such as CH3 attached to aniline, then this is going to increase the basic strength, because the alkyl groups are electron donating. Then we are going to see the chemical properties one after the other. Just if you are watching, press the like button. Press the like button and support us, guys. Okay, now let's move forward. Okay, let me move forward. I'm just watching. If anyone is watching, you can put the comments over here. Okay. Acylation. We are going to see the acylation reactions right now. Acylation. What is acylation? When the amine is treated with acid chloride. That's the OH group in the acid is replaced by a halogen that's called as acyl halide. Then the primary and the secondary amines are going to react with acyl halides. See, this is a primary amine. I'm writing it over here. RNH2. I'll write it this way. That can react with ClCOR. And this is going to give you HCl is removed, being removed. So you get RNHCOR. You're going to get the amide. If you treat this RNH, if it is a secondary amine, and if you're going to treat it with the acid chloride, then you get RNR. This HCl will go, and you're going to get the secondary amide. And if you don't have hydrogens over here which can be replaced, this won't react with acid chloride or acid anhydride or ester. Otherwise, they'll react the same way. Instead of acid chloride, you have to take the ester and also the anhydride, and the products will be, if you take the anhydride then or the ester, then the one more compound will be the corresponding acid. So the even the aniline, that also reacts in the same way, resulting in the formation of acetanilide, where one of the hydrogen from here will go, not from the benzene ring, from here will go, and that forms the acetanilide. So whenever the reactions of NH2 happens, first you have to protect this group by treating it with the acid chloride so that the this group is protected, and then you do the substitutions. Once the substitution is done, because sometimes this hydrogen can be removed. So once the substitution is done, once the protection is done, then you can go for the substitution. After the substitution, you can deprotect this group. Then we are going to go for the carbilamine reaction. Aliphatic, whenever we say the carbilamine reaction, then what we are going to do over here is, this is called as Carbillamine reaction. At the end product is isocyanide, or which is also called as Carbillamine. That's cyanide is RCN, isocyanide is RNC. So how do you do the Carbillamine reaction? You take the aliphatic or the aromatic primary amine. Only primary amines give this test. And those amines are treated with chloroform and ethanolic KOH, and they are heated. So what you're going to get, 3K will go with Cl, and hydrogens are removed with oxygen as water, and Rn with one carbon, that's going to give you RNC, which gives you the suffocating, very bad smell. So the reaction is generally not done in the laboratory, and this isocyanide which is produced is also hazardous. So how the reaction proceeds? CHCl3 in the presence of KOH. If you have CHCl3 in the presence of KOH, the OH is going to take a proton from here, and you get a CCl2, a CCl3 with a minus charge, which gets converted into Cl minus, and our dichlorocarbene is produced, and the lone pair of electrons on the nitrogen attack the dichlorocarbene, and now this dichlorocarbene, the N gets a positive charge, and CCl2 gets attached over here. Then the hydrogen shifting happens, and then after this, in the presence of the base, excess of the base, it gets converted into phenyl isocyanide. This is a very, very important reaction when in board exams as well as the competitive exams. The reaction of amine with the nitrous acid. Nitrous acid is very unstable, so it is prepared in situ by the reaction of sodium nitrite and the acid like HCl or the H2SO4 mineral acid. So whenever you say it is unstable, you are not going to keep it prepared in the laboratory. It's stable only at a low temperature, very low temperature, such as below 5 degrees Celsius. So this reaction should be carried out in a very low temperature condition. Better to use ice. So how is this reaction done? Sodium nitrite reacts with HCl to give HONO, that is nitrous acid. Now, so the primary aliphatic amine, in the presence of NaNO2 and 2HX, 2 molecules of acid, NaNO2 and 1 molecule of acid react to give HNO2. That HNO2 reacts with primary or aliphatic or the aromatic amine, and that gives the diazonium salt. Diazo because there are two nitrogens and there is a salt formation, and now the nitrogen gas escapes and you get R plus and the X minus. The carbocation is formed. In the presence of water, this may result in the formation of alcohol. And in the presence of, if you remove the hydrogen from the carbocation, you may get alkene. And if you treat it with any halogen or the halide ion, you may get the corresponding alkyl halide. The same reaction is followed by aniline also. So they may give directly HNO2 or the mixture of any NO2 and HCl. Both are one and the same. When it is treated with HNO2, then you are going to get N2 Cl, N2 plus and Cl minus. Then when it is treated hydrolyzed, you're going to get phenol along with N2 plus HCl. That's how the, or NaCl. This is how the reaction proceeds. So the primary amines react in a different way. The secondary amines react in a different way. Tertiary amines react in a different way. The primary amines will give you the alcohol. Secondary amines will give you R2. The two R groups are attached and they give you NO. That's called as nitroso. And if you are going to treat them with the tertiary, then they are going to give you HONO. That's the salt. The salt formation will take place. Okay, now let's move on to the question answer discussion topics. How do you proceed from here? So let's start. Which of the following is a primary amine? Whenever you say the primary amine, see how do you eliminate the wrong answer first? N-methyl aniline. So anything with N cannot be the primary amine. Trimethyl, there are three methyl groups. This cannot be. Dimethyl, there are two methyl groups attached to the nitrogen. This cannot be. Ethylene diamine, this can be the answer. What is ethylene diamine? Ethylene is CH2. CH2, there are two carbon atoms to which NH2 is attached. So only one hydrogen of ammonia is being replaced by this. So this is called as primary. Okay. The amine formed from an amide by means of bromine and alkali has same number of carbon atoms as that of amide, one carbon lesser than that of amide, one carbon more than that of amide, two more carbons than that of amide. First, you understand what exactly is the question. The amine formed from an amide. You are going to treat amide and bromine and the alkali. This is nothing but the Hoffmann bromamide degradation. Degradation in the sense the number of carbon atoms decreases. So less, you see decreases is less. Only one option, that's B, that should be the right answer. So we'll still write the reaction R CONH2 is amide. When it is treated with bromine and alkali, say NaOH or the KOH, what is that you are going to get? This group goes from middle and you get RNH2, and the byproducts will be NABR and Na2CO3. And then you have to balance the reaction, and RNH2 contains one carbon. Here there were, say this was CH3. If it was CH3, in the final product you get CH3NH2. There were two carbon atoms over here in the reactant, and in the product you have just one carbon atom. So the one less carbon than that of amide will be the right answer. When methyl iodide is heated with ammonia, the product obtained is methylamine, dimethylamine, trimethylamine. This reaction is called as ammonolysis. If you are watching, you can comment. I didn't check that. Just give me a second. I'll be checking this. Is anyone watching, or is anyone giving their answers? Yeah. So now we have, sorry, I'm just checking if you're watching this video. Yeah, here we go. Yes, we don't have any option, any answers over here. Let me proceed then. Okay. So when methyl iodide is heated with ammonia, this reaction, particular reaction, is called as ammonolysis or Hoffmann ammonolysis, where you're going to treat methyl iodide, that CH3I, is treated with ammonia. When you treat it with ammonia, you can get the primary amine with CH3NH2 as a formula. You can get CH3NHCH3 as one more product, or you can also get CH3NCH3CH3. The mixture of primary, secondary, and the tertiary will be formed. So all the above amines. In case if you take alkyl halide and treat it with excess ammonia, then the primary amine will be the major product. So you have to see what exactly the reaction conditions they have given. The secondary amine is, what do you mean by a secondary amine? An organic compound with the 2NH2 group. What do you call that as? If there are two NH2 groups, you call it as diamine, right? A compound with two carbon atoms and one NH2 group. This can be called as primary amine. A compound with an NH2 group, secondary amine, the NH2 group on the carbon atom, which is in the number 2 position. So you have this and then you have NH2 over here. And NH2 group on the second carbon. This is not called a secondary amine. This is a, okay, can you call it as secondary amine? We'll see a compound in which two of the hydrogens of NH3 have been replaced by organic groups. In NH3, you are replacing two by organic groups. Okay, NH2 is attached to this carbon. This carbon is called a secondary carbon, but this is not a secondary amine. Okay, here both the NH2 are there. So this is also a primary amine. And here you have two groups replaced by alkyl group. So this could be the secondary amine. So the right answer would be option D. We are going to the next question over here. Reduction of nitroalkanes. What is nitroalkane? RNO2. You're going to reduce it in the presence of sodium over ethanol. So what is the product? The oxygen gets replaced by hydrogen. So you get RNH2. So the product will be definitely amine. It's not the diazo compound or anything else. The next question. Chloroform when treated with aniline and the alcoholic KOH. What this reaction is? This reaction is called as Carbillamine reaction. What you're going to do over here, you take an amine, NH2. This is treated with chloroform, CHCl3, and heated with KOH. So what is that you're going to get? The KCl, 3 molecules of KCl are eliminated, water molecule is gone, and hydrogen is also gone. You get RNC, that's phenyl isocyanide. You get this product. N triple bond C with KCl and the H2O as a byproducts. So this is called as phenyl isocyanide, where NC is a group attached. So the correct answer would be B. Which one is the weakest base? How do you find it out? Ammonia, dimethylamine, trimethylamine. So dimethylamine, trimethylamine. So what do you think? We know that the secondary amine, dimethylamine is a secondary, trimethylamine is a tertiary. This is a primary. This is just ammonia. So secondary are more basic than the primary, than the tertiary, and than the ammonia. Because in case of secondary, you have the solvation because of the presence of hydrogen. You have the presence of electron donating plus I groups and no bulkiness, where here also you have the solvation. You have plus I effect. Here bulkiness comes into picture, whereas here there are no electron donating groups, so this will be the weakest base. Amongst the following, the strongest base in the aqueous medium is, how do you find it out? What do you mean by the strongest base in the aqueous medium? How do you find it out? In the aqueous medium, yeah, whenever you say the aqueous medium, in this one, there is solvation as well as there is plus I effect due to methyl group. Here, the CN group is present, so this is less basic. Here, it's a secondary amine. So what is present? Solvation is there. Along with the solvation, you also have the plus I effect. And here, though there is a presence of CH3 group, the lone pair of electrons are involved in the resonance. So when you compare all these factors, the solvation and the inductive effect increases in the aqueous medium. So the correct answer would be option C. That's a secondary amine. Which one of the reagent would not be a good choice for reducing an aryl nitro compound in the aryl nitro compound to amine? What do you think the answer is? Yeah. So keep supporting if you're watching. So, so you start with the nitro compound, aryl nitro compound. So we'll take nitrobenzene, and if you treat it with hydrogen over platinum, this will definitely give you the aniline. And lithium aluminum hydride in ether. And then Fe over HCl and also tin over HCl. These are going to react in the same way, and this will give you the aniline. That's the amine compound. But this reaction is not going to happen in the presence of ether. So the correct answer would be option B. The source of nitrogen in the Gabriel synthesis of amines is. So in the Gabriel Thalamide synthesis, you get amines, right, at the end of the reaction, and the source of nitrogen over here. What would be the answer? So how do you do the Gabriel Thalamide synthesis? C double bond O, C double bond O, NH. You start with Thalamide and you treat it with KOH solution where you get potassium salt of Thalamide. C double bond O, N, K plus N minus, and C double bond O. So potassium Thalamide, C6H4, CO2, N minus and K plus. This will be the source of nitrogen in the Gabriel synthesis. That's all for today. If you have any questions, you can comment it in the chat section, or soon after the class. If you have any comments, please drop down. We are going to look into it. Thank you for watching. Keep